Okay, ladies and gentlemen, let's come up to our final center. It's called a circumcenter. Now, a circumcenter is created by three perpendicular bisectors. Now, let's do a perpendicular bisector of the center. If you remember, a perpendicular bisector has to be over halfway. So let's choose the 3t here. Over halfway. So if I come over here, I come up with 3t. Where'd my 3t go? There's my 3t. Okay. And now I'm going to create a perpendicular bisector. Now, in this case, it does happen to go right through this vertex. It will not always happen like that. In fact, our next one will be very clear that it won't happen like that. It does split this side and this side congruent, but what it means is I've drawn unintentionally a triangle that is really close to isosceles. So we're going to turn our paper over. We're going to do a perpendicular bisector from here. And we'll just choose, I don't know, let's choose the one by the 4 this time. Okay, there's one. And let's come over here and choose the one right by the 4. Here we go. And now you'll clearly see this time, because this way is not the isosceles way of the triangle, that when I create a perpendicular bisector, it is indeed 90 degrees. If you don't believe me, we can look here. 90 degrees, okay. And it does definitely break these two in half, but it does not go through that vertex, because the perpendicular bisector is controlled by the 90-degree angle, not the vertex like a median would be. So let's turn it around. Let's do one more. And I need a perpendicular bisector here. So there's my corner. And let's choose the 4 again. Here you go. And in this case, choose the 4 again. Where'd he go? Okay. And I draw my perpendicular bisector. There he goes. There he goes. Now, in this case, you'll notice I have a little bit of an open gap here. A little bit of the open gap would obviously be somewhere I wasn't totally 100% on my right spots, but it's clear to see that that point right there is going to come together. It's a point of concurrency. And remember, a point of concurrency is where multiple lines come together at the same point. Point of concurrency. Now, a circumcenter has another special property. It means that it can be, you are circumscribing the circle. Let's see if that's going to do it. Okay, it's the one right beside there. Do that. Just touches, just misses. Again, and maybe I have my thing a little bit moving. Okay. But now I can create a circle all the way around the triangle. And now this triangle is circumscribed. Circumscribed, meaning around the triangle. So circumscribed, which means it goes around the triangle. And again, this one would be 1, 2, 3, 1, 2, 3, because those are congruent. Because that makes it perpendicular and bisector. It's a circumcenter. So by putting the 3 different constructions or 4 different constructions to work, we can not just create simple things like copying a segment, copying an angle. We can create much more complex things like circumcenters. All right. And this is something actually that I did when I was trying to put a router together. And what I had was I had a router table, and that router table had 3 mounting holes. But on the router itself, the 3 mounting holes were in different spots. And so I had to create a place where this triangle and this triangle from the 3 mounting holes would have exactly the same centers. And it becomes very important in some of these applications because just like a wheel, if its center is slightly off from the true center, your entire car will shake, your entire car will rattle. If in a case of the tool, if you have something that's off center, it's not going to function. In fact, it becomes exceedingly dangerous. And so there are applications where by trying to fit a router on a router table, I was simply able to take a piece of wood, create indentations, connect those indentations, connect the indentations, and then from those indentations, begin creating a center point. And by creating that center point, I was able to find the mounting holes correctly so that when I put them on the table, the router fit correctly and does its job at 9,000 RPMs. So there are applications for some of these beyond just the logical process of trying to make them. So just to give you an idea of what might be an application.